Hello everybody, welcome into another lesson. So today we are going to talk about quadrilaterals. Quadrilaterals are nothing more than four-sided figures. I know we've dealt largely with triangles lately, but today we're talking about quadrilaterals. Lateral meaning side, quadra meaning four. That's how you can think of it. And the sum of the interior angles of a quadrilateral, they all add up to 360. So if you add up the measure of the four angles together, you'll get 360 degrees. So that's just a basic quadrilateral, nothing special, but there are several special types of quadrilaterals that we're going to talk about. For example, we have here this type of quadrilateral is called a trapezoid. We have a trapezoid here. So, what makes a trapezoid a special quadrilateral? Well, you got two bases here, and both bases are parallel to each other. What I am putting up here, that mark I'm putting, those arrow marks I'm putting on the bases, those are called parallel markers. So we have congruency markers and we have parallel markers. Well, the bases of a trapezoid certainly are not congruent, but the bases are parallel to each other in a trapezoid. The first quadrilateral I drew had no parallel sides, no congruent sides. It was just a regular quadrilateral. But a trapezoid, both bases are parallel to each other. Alright? Then, the one I'm about to draw here will take us through our next several. Then you have here what is called a parallelogram. You have here what is called a parallelogram. A parallelogram is when you have not only are both pairs of opposite sides parallel to each other, both pairs of opposite sides are also congruent to each other. So we have congruency markers and parallel markers. So in a parallelogram, it's a quadrilateral with both pairs of opposite sides are parallel to each other and they're also congruent to each other. So the left side's congruent to the right, the top side's congruent to the bottom side, and the top side's parallel to the bottom side, the left side's parallel to the right side. So that makes up a parallelogram. So parallelogram's kind of the foundational for what we're going to be doing for the next three examples here. What I am drawing is what everyone's probably used to, which would be a rectangle. This is a rectangle. A rectangle is unique in the fact that it has four right angles for its angles. A rectangle is a parallelogram. It's a parallelogram that has four right angles. A regular parallelogram, none of the angles are right angles. They're acute and obtuse. In a rectangle, you have it where, just like a parallelogram, both pairs of opposite sides are parallel and congruent to each other. But also you have four right angles. That is a rectangle. So parallelograms are not always rectangles. You just could have parallelograms where you have acute and obtuse angles. But a rectangle is always a parallelogram. That's a unique relationship, because rectangles, you just have four right angles, they still add up to 360 degrees, and both pairs of opposite sides are congruent and parallel to each other. then I'm going to draw something here which we haven't really talked much about. Let me draw a little bit bigger, shall we? A little bit bigger. We have here, this is called a rhombus. We have a rhombus. With a rhombus, it's still a parallelogram, but both pairs of opposite sides are parallel to each other. However, all four sides are congruent to each other. In a rhombus, all four sides are congruent to each other, but both pairs of opposite sides are parallel to each other. But a rhombus, you have acute and obtuse angles in it. But it's a parallelogram where all four sides are congruent to each other. Then last but not least, I will draw something else everyone's used to. Everyone should know what that is. That is a square. We got a square, in which a square has four right angles. So all the angles in a square are right angles. Both pairs of opposite sides are still parallel to each other, because it's a parallelogram and it's actually a rhombus too. But all four sides in a square are congruent to each other. So I set up the congruency markers and the parallel markers. In a square, you got four right angles, but all four sides are congruent to each other. So let's break this down. You got a parallelogram where you have two pairs of opposite sides that are parallel to each other and congruent to each other. You have a rectangle that's a parallelogram that has four right angles in it. That's what makes it a rectangle. It has four right angles. Then you have a rhombus where you have, it's where all four sides are congruent to each other, but both pairs of opposite sides are parallel to each other. Then you have a square that is a rhombus, and it's also a parallelogram. It's a square because it has four right angles, both pairs of opposite sides are parallel to each other, and all four sides are congruent to each other in a square. So those are the special types of quadrilaterals, but for every quadrilateral, what stands true is the sum of the interior angles will always be 360. Now we are going to draw some quadrilaterals here. We're going to figure out the missing angle measures to start with. Alright, so we have this angle here at 65 degrees. We have this one being 109 degrees. We have this one being 115 degrees. The unknown is x degrees. So we want to find the missing angle measure x for this quadrilateral here. Again, we want to use the fact that the sum of the interior angles of a quadrilateral equal 360 degrees. So what you're going to do is you're going to take that the angle x, you'll take the measure of angle x plus take another angle, the 115 degrees, plus the 65 degrees, plus the 109 degrees. You're going to set all that equal to 360 degrees. Alright, so you add up your four angles together, set them equal to 360 degrees. You'll treat your measure of angle x like a variable. So first thing I would do, add up your 115 plus 65 plus 109. which I'm going to bust out my calculator for. So let's see. 115 plus 65 plus 109, that comes to 289. So you'll get the measure of angle X plus 289 degrees is equal to 360 degrees. Okay? Well, great. We have the measure of angle X plus 289. We just want to find the measure of angle X. Well, we have plus 289. We need to subtract 289 from both sides. So let's go ahead and do just that. We will subtract 289 from both sides, because what you do to one side, you actually got to do to the other also. Alright, so on the left side, 289 minus 289, that's 0. That just leaves the measure of angle X by itself. You'll set that equal to whatever 360 minus 289 is. I can tell you right now it's 71. So therefore, the measure of angle X, your missing angle, is going to be 71 degrees. That's exactly what you would get. Angle X is equal to 71 degrees. It's a lot like when we solve for missing angles of a triangle, only you have a quadrilateral. Instead of like a triangle where it equals 180, in a quadrilateral it equals 360. But I got more examples of this. Alright, what's the next one here? Alright, there's our next quadrilateral. This angle equals 96. This one equals 110. This one equals 52 degrees. This one is X. Okay, so we got to solve for our missing angle of X degrees. What we're going to do here is we're going to take all four of these angles, we're going to add them together, set them equal to 360. So you'll take the measure of angle X plus 96 plus 110. I should probably put the degree symbols, plus the 52 degrees. You'll set that all equal to 360 degrees. Alright, first thing I would do, add up your 96 plus 110 plus 52. That's probably the first thing I would do. 96 plus 110 plus 52. That comes to 258. So the measure of angle X plus 258 degrees equals 360 degrees. Alright, well we have the measure of angle X plus 258. We just want to find the measure of angle X. So we're going to have to subtract 258 from both sides. So let's go ahead and do that here. You have the measure of angle X plus 258 degrees minus 258 degrees. That'll be equal to 360 degrees minus 258 degrees. So on the left side, 258 minus 258, that goes to 0. You just get the measure of angle X. That'll be equal to 360 minus 258. That'd be 102. So the measure of angle X that we were searching for is 102 degrees. That's what you would get. Alright. Let's spice it up a little bit. Perfect. So we got x degrees here. We have 3x here. I'll just say x. It's going to be a lot easier to do it that way. We're going to have 120 here and 128 here. So it looks like we have two missing angle measures we need to find. Well, that's okay. We're going to do this much the same way. Even though we have two missing angle measures, you're still going to add up the sum of all these, set them equal to 360. So you'll take x plus your 3x, then you'll add 120 to that, plus the 128 degrees. You're going to set all this equal to 360 degrees. Alright, so first thing I would do on the left side, add your like terms. Add like terms means the x plus 3x, that would be 4x. Then add your constants, 120 plus 128, that would be 248. So you get 4x plus 248 degrees equals 360 degrees. Alright, now we got the 4x plus 248. We just want to get 4x. So you got to subtract 248 from both sides. So 4x plus 248 degrees minus the 248 degrees equals 360 degrees minus 248 degrees. Well, the left side, 248 minus 248, that's 0. That just leaves 4x by itself. That'll be equal to 360 minus 248. That'd be 112. So then you got to divide both sides by 4 to get the x by itself. We do that. The left side 4's cancel out. You'll get x is equal to 112 divided by 4. It'd be 28. So x equals 28 degrees. Well, that's one angle. We got to solve for the 3x also. We got x being 28. We need to solve for 3x. So you'll just take 3 times 28 degrees. That should equal 84 degrees. So your other angle that you were trying to look for was 84 degrees. So you got x being 28 degrees, 3x is 84 degrees, because you'll take 3 times your 28 for your x. 3 times x, 3 times 28, that equals 84 degrees. So 28 degrees and 84 degrees would be your missing angle measures. And I have another problem like it. All right. One more problem like this. All right. So we got x here. We have 135 degrees here. This is x plus 5, and then this is 2x. So all of a sudden, we have 3 angles we got to solve for. Well, once again, you're still going to do it the same way as you did before. You're going to set all 3 of these equal to, all 4 of these angles rather equal to 360 degrees. So let's go ahead and do that. You'll take x plus the quantity of x plus 5 plus the 2x plus the 135 degrees. You're going to set all that equal to 360 degrees. Well, I would still go through, add up your like terms. So here you have x plus x, which is 2x plus 2x, that's 4x, plus you have your 5 plus 135, that'd be 140. So you have 4x plus 140 degrees is equal to 360 degrees. Alright, well we have 4x plus 140, we need to just get 4x. In order to do that, we got to subtract 140 from both sides. So you do 4x plus 140 degrees minus 140 degrees equals 360 degrees minus 140 degrees. Well, the left side, 140 minus 140, that goes to 0. You just got 4x by itself. The right side, 360 minus 140, that's 220 degrees. So you got 4x is equal to 220 degrees. Well, we got 4x. We want to solve for just x. Divide both sides by 4. Let's go ahead and do that here. Left side, 4's cancel out. You'll just get x is equal to 220 divided by 4. I think that would be, let me see here. Yep, 55. So x equals 55 degrees. We solve for one angle, we got to solve for two more, because we got x equals 55 degrees, but we also have that x plus 5. You'll stick that 55 in for x, so you'll have 55 degrees plus 5. That would equal 60 degrees. So the second angle is 60 degrees. You have 55 degrees for x, 60 degrees for x plus 5. Then to solve for the 2x, you'll take 2 times 55 degrees, which would equal 110. So your third angle is going to be 110 degrees. So x was 55. Put the 55 in for the x plus 5, you'll get 60 degrees. Do 2 times 55 for the 2x, you'll get 110 degrees. So your missing angles are 55, 60, and 110. That's exactly what you would get. Alright, I think we've solved for enough angles. Let's do a few exercises that are a little bit different here. Alright. Let's see here. We got a shape that has 4 right angles. So it's got 4 right angles and it has 4 congruent sides. A shape that's got 4 right angles and 4 congruent sides. What's the best term to describe this quadrilateral? So it has 4 right angles and 4 congruent sides. It would be definitely a square. We would definitely say this is a square. That's its primary shape, is a square. Because a square has, it's a quadrilateral, 4 right angles and 4 congruent sides. It would also be a rhombus because it is a quadrilateral, 4 congruent sides. It just happens to have 4 right angles, but it's also a rhombus. What else? We could say this is a rectangle, certainly. We can certainly say it's a rectangle because it's a quadrilateral with 4 right angles, but it just so happens all 4 sides are congruent, where usually in a rectangle both pairs of opposite sides are congruent, but, well, you have that, both pairs of opposite sides are congruent, but all 4 sides are congruent, so it's definitely a rectangle, which would have to mean it's a parallelogram. It's a quadrilateral with both pairs of opposite sides congruent, and it has all the sides congruent, so it's definitely a parallelogram. So that's a good way to describe that shape. Let's do another shape description here. Alright. Let's see here. So, this is a quadrilateral that has both pairs of opposite sides congruent and both pairs of opposite sides parallel. How would you describe this shape? It's for sure a parallelogram. This is for sure a parallelogram. Now, let's see here. Could it be a rectangle? No, because they don't indicate that the angles have right angles, so it can't be a rectangle. This just proves that all rectangles are parallelograms, but not all parallelograms are rectangles. There's a big difference. Could it be a rhombus? Certainly not, because only both pairs of opposite sides are congruent. In order to have a rhombus, you'd have to have all four sides congruent. And could this be a square? Certainly not, because again, they don't indicate that there's right angles in this quadrilateral. You need to have right angles in order for it. All four angles have to be right angles. So the only shape we can definitively say this is a parallelogram. One more here. Alright, we got a quadrilateral with four congruent sides. We could definitely say this is a rhombus because all four sides are congruent. If it's a rhombus, that means it's a parallelogram. It's for sure a parallelogram because in a parallelogram, at least both pairs of opposite sides are congruent. We definitely have that here. We actually have all four sides are congruent, so it's a parallelogram. Is this a rectangle? No, because it doesn't indicate any right angles. Same reason why it's not a square. You don't see any indication of right angles in this quadrilateral. So you have this shape being a rhombus and a parallelogram. Alright, we're gonna do four statements here. Let's see. Determine if each statement is always, sometimes, or never true. So we got four statements we're about to make here. We want to determine if these statements are always, sometimes, or never true. First statement. A square is a rhombus. A square is a rhombus. Is this statement always, sometimes, or never true? Well, in order to answer that, let's draw a square. Let's go ahead, let's draw ourselves a square. That might help to have an illustration here. Square, you have four right angles, right? Both pairs of opposite sides are parallel to each other and congruent to each other. But in a square, all four sides are congruent to each other. If we remember right, a rhombus was a quadrilateral where still both pairs of opposite sides are parallel to each other, which you have with a square. Both pairs of opposite sides are parallel to each other and all four sides are congruent to each other. That was true for a rhombus. Well, a square, has all that criteria, and it adds that it has 4 right angles. So I'm going to say it's always true. It is always true. A square is always a rhombus. That is always true. Alright, we got 3 more statements here to work through. A parallelogram is a rectangle. Alright, so a parallelogram is a rectangle. Is this always true, sometimes true, or never true? Well, let's do a drawing here to help determine the answer. Let's draw ourselves a parallelogram, okay? A parallelogram, both pairs of opposite sides are parallel. That much is absolutely true. Both pairs of opposite sides are congruent. Okay. There's your parallelogram. So that's a parallelogram. A rectangle, it would almost appear like it's always true, but a rectangle, you have right angles added into it. You've got right angles added into rectangles. So let's look at these side by side. You have a parallelogram. Both pairs of opposite sides are parallel and congruent to each other. You have a rectangle. All those things are true about the rectangle, except a rectangle adds the fact that all 4 angles are right angles. Now, it's true a rectangle is always a parallelogram, but it's not always true that a parallelogram is a rectangle, because this parallelogram is missing the right angle factor. So that is sometimes true. So that's going to be sometimes true. If you don't have right angles in the parallelogram, then it's not a rectangle. So sometimes it's true. Alright, we got 2 more statements to work through here. Alright, what's the third statement? A rectangle is a square. A rectangle is a square. Well, once again, let's do a drawing of each. Let's draw ourselves a rectangle. Alright. Rectangle, of course, both pairs of opposite sides are parallel and congruent to each other. That's for both pairs of opposite sides in a rectangle are parallel and congruent to each other, and they have 4 right angles. A square, on the other hand, you still have 4 right angles. That much is true. That much hasn't changed. Both pairs of opposite sides are parallel to each other, but all 4 sides are congruent to each other. So by definition, let's work backwards. A square, you definitely have both pairs of opposite sides are parallel and both pairs of opposite sides are congruent. In fact, all 4 sides are congruent, and you have right angles. So by definition, a square is a rectangle. That's true. But a rectangle is not necessarily always a square, because you don't have all 4 sides congruent to each other. So this is sometimes true. This would also be sometimes true. It's not always true. due to the fact that rectangles don't always have all four sides congruent to each other. That's why it's sometimes true. Then we got one more statement to work through. A parallelogram is a quadrilateral. A parallelogram is a quadrilateral, a four-sided figure. That's always true. We don't even got to really draw it. We know that's always true. Now, a quadrilateral may not always be a parallelogram, but a parallelogram is always a quadrilateral. It's always a four-sided figure. So we didn't even have to do much work for that one. But yeah, quadrilaterals being four-sided figures, the sum of their interior angles equals 360 degrees. If you want to solve for missing angles, you just set all the angles, add them together, set them all equal to 360. Treat your missing angles like variables. That's the best way to do it. And just work through the algebra of that. And then, remembering as I went through the definitions of quadrilaterals, trapezoids, parallelograms, rectangles, rhombuses, and squares. If you can remember all that we've talked about, we've gone through, you've got down quadrilaterals. But the next lesson, we're going to talk about polygons in general. And we'll learn some interesting stuff about shapes with even more than four sides. So, hope everyone has a good night. Take care.